For our project, we created a database for an imaginary pet store called Petopia, the largest and most differentiated pet store in the world. Petopia is known as a one-stop shop for all of its customers' needs, as well as carrying a wide range of animals.
Our database will serve multiple functions such as tracking adoptions and pet medical history, as well as inventory, grooming, and kenneling.
It will also store information on every employee, customer, and supplier.
This will help consolidate Petopia's business into a manageable system.
Now we'll pass it back to Amanda to talk about how we converted the business model into an ER diagram.
After we decided on the scope of our project, the next step was to convert this business model into an ER diagram, carefully following Petopia's business rules. To do this, we first separated each business segment into its own entity. As you can see, manager, product, supplier, customer, pet, groomer, and kennel each have their own entity with their respective attributes.
Pet also has a weak entity called medical history. To explain this diagram, we will tell you a little bit more about Petopia's business model. At the top left, you'll see the entity for managers. This entity allows us to store information on every store manager. It has attributes for manager ID, which is the primary key, as well as name, address, and phone number. To the right, entity product represents all of the different products Petopia carries on its shelves. A manager may manage one or many products, and each product has one and only one manager. The entity also has attributes for its primary key product ID, as well as product name and price. Next, you'll notice the entity for supplier. This keeps track of who Petopia buys all their products from. A supplier may deliver one or many products, and a product may be delivered by one or many suppliers. Attributes include its primary key, supplier ID, as well as name and address. The next entity is customer. A Petopia customer may buy one or many products, and a product can be purchased by 0 or many customers. Attributes include primary key, customer ID, along with name, address, and phone number. Further down the diagram is pet, which is where Petopia will store information on every animal in their care. It has attributes for its primary key, pet ID, as well as sex, breed, date of birth, and subsequently age. It has relationships with customer and groomer, but we're going to talk about those later. Groomer has attributes groomer ID, which serves as its primary key, along with name and availability. The entity for kennel has attributes kennel ID, which serves as its primary key, as well as name and room number. At Petopia, a pet may stay in many kennels, and a kennel may accommodate many pets. Finally, medical history helps Petopia keep track of its pet's medical records, and has attributes signifying if the pet is neutered or vaccinated, as well as mHistory ID, which serves in combination with pet ID as the entity's primary key. According to Petopia's business rules, each pet may have up to one medical history, and each medical history may belong to one and only one pet.
In order to explain our ER diagram to table process at a sufficient depth, we have decided to focus this video on the entity in our diagram for pet and its relationship with customer and groomer. Because Petopia's business rules state that a customer may own many pets, but a pet must belong to one and only one owner, pet has a one-to-many relationship with customer.
For this reason, customer ID must become a foreign key in the pet table in order to uniquely identify each instance of pet. This makes sense logically because if we were to use this database to identify a single pet and the foreign key was not listed, we would not know the pet's owner.
Petopia has another business rule about its grooming service. The rule states that a groomer may groom many pets and a pet may visit many groomers. This means that pet has a many-to-many relationship with groomer. Because of this relationship, we must create an associative entity called pet groomer in order to uniquely identify each instance in which a pet is groomed.
After we finished designing the ER diagram and laying out our tables, we started the process of normalization. The goal was to reach third normal form for all of our tables.
The first step of normalization is to make sure each table has a primary key that can uniquely identify each instance in that table, and to remove any duplicate values. By paying attention to the cardinality of each relationship, keeping an eye out for the multi-valued attributes, and following the business rules, we guaranteed our diagrams table would automatically be in first normal form.
The next step is to remove any partial functional dependencies. Partial functional dependencies can only occur if there are composite primary keys. Because we designed all of our original tables to have a single primary key in the form of an ID number to uniquely identify each row, our tables are also already in second normal form.
You may have noticed that we have composite primary keys and the associative entities resulting from the many-to-many relationships. For example, our table Pet Groomer has a composite primary key composed of Groomer ID and Pet ID. However, none of these tables have attributes that are partially dependent on one of these keys. Instead, each attribute in this table is dependent on the composite primary key as a whole.
The last step is the removal of any transitive dependencies. Our diagram was designed from the start without transitive dependencies, so all the tables are now automatically in third normal form, and the normalization process is complete.